Hi, very good evening to all of you. This week we are discussing this new project which is to build an Excel add-in using VBA and how we can integrate this into our worksheets. Now, this is something which you would be doing most often at your workplace. So, when you join a department dealing with actuarial work, an organization dealing with actuarial work, you will have to often work in Excel, make a VBA macro, a VBA code, which can be used again and again in the future projects. And this project, what we are doing in CAST, is basically a jump start for that to understand how VBA can be used to build an Excel add-in and how that add-in can be included into the other workbooks, other Excel worksheets, and how we can use this to reduce the amount of time that we would need to do a certain task. Now, we have asked you to calculate actuarial functions for any given mortality table, but you can extend this idea to build something else, something like, say, a chain ladder model or a GLM or something which uses a stochastic interest rate. So the opportunities are endless. The options that you may think of using an Excel add-in are really endless, and there is so much you can do with this technique. So this particular session here is to discuss to help you understand how an Excel add-in can be made, and I'll walk you through one of the add-in that I've already shared, one of the VBA code that I've already shared in the group. So in a way, I've already given you a solution to this project. But what we have shared is just one function, which is for EPV of the whole life assurance function. You can actually do a lot more than that. You can, if you're good with this, if you're quick in coding, then you can also use this idea to make an add-in which can calculate the EPV of all the functions, whatever you have studied in School 1, or other similar functions that you may be studying maybe in another course or at your workplace or in your other courses. So the idea can be extended to any calculation which is kind of redundant. So for example, I need the EPV of say a whole life assurance at 4%, 5%, 6% in the same calculation, then I need not write this code to calculate EPV three times. I just have one function, one add-in, and I just call it at different rates and get my value. So that's the advantage we have when we are using, software, or when we are using various computing techniques. So we should try and make our professional life easier by using options like Excel. So in the project, it was told to you that all you have to do is use the QX data which is given to you. Some story was there along with the project about your client is from Mongolia and all that, but I guess you're smart enough to understand this is to just engage you. And it says, of course, important thing is to comprehend the information which is given, and it clearly says that it is to calculate the actuarial function for human beings aged 17 to 120. I'm sorry. Then QX values to be used, but some 10% loading was required, right? So 10% loading would mean if you have standard QX value as 0.00092 for certain age, then it would become 1.1 times of that 0.00092. Then, although the project only asks you to calculate EPV of whole life assurance and annuity due, you can really go beyond this and calculate for term life, for continuous cash flows, for temporary annuities, joint annuities, and believe me, students in the past have done that. They have one of them calculated for 10 different functions. The other person made sure that it was not just AM92 but other mortality tables also used. So there is a lot of application to to such add-in that you create here, because this is a this is something which you can take credibility for. You can showcase this in your resume. You have worked on such add-in, and this is a real value addition to your profile when you go for a job interview, when you talk to people about your achievements. And we have made a lot of options for students like you who are doing CAS especially, to showcase their talent, to showcase their work, using R, Python, or Excel. And once you make something which can be shared with others, we will provide you a hosting platform where you can put up your, put up your work, and it is publicly accessible using a link. We have already done it for students of level 2. There is a portal called as r.actuarylife.com. I shared this on LinkedIn few days back, where students who are working on Shiny apps can publish, or other R projects can also publish their work. And we give them a publicly accessible URL for their work, for their portfolio, and they can use these links in their resume, because this is like a real time validation of the work that you are doing. If you put something on internet, and if you let the whole world know about it, you are validating your work, which is publicly accessible, and it is a real good thing to do, considering the difficult situations that we have, especially in actuarial employment space. So I would highly recommend you to do that. If you make something, which can add value to somebody else's life, or which can help others, you should surely share that. And in case you need help with hosting such project of yours on internet, please do ping me on LinkedIn. I'll help you with it. Then it was further given that the input table has to be there in a worksheet and can be used by the add-in. Now this is one possible solution. You can also reference to this mortality table, using a global variable, which of course is not needed as per project. So it is assuming each time you use the add-in or the function into an Excel sheet, the data is already present in one of the sheet, and we will see in a while that that sheet is called mortality. So that assumption is being taken, but use your imagination, and you can call that sheet anything, or make it globally accessible by the VBA code, so that you need not paste that table each time in the workbook that you're working on. Then custom function should work in Excel and allows the user to pass age, interest, and required decimal points. Now this was something which some students got confused with. Why this decimal point? So it is quite possible when you are doing some work practically, that the kind of number of decimals that we need based on the project requirement may vary. So some projects may ask you to be as accurate as 9 decimal places. Some may want just 3 decimal places. So it all depends upon the project requirement. So having the decimal points as one of the variable allows you to make your program more customizable. So this was just to help you understand that this is the kind of customization you might be asked to do, when you use such things at your workplace. Then the output which is required is to have a Excel add-in file which can calculate the functions in a worksheet. Also plot the values of calculated actuarial functions for the modified mortality using an Excel chart. So what you need to do is, once you have all the values calculated from age 17 to 120, then use a chart function in Excel to also display how the values are changing. So suppose you have worked on 4 different functions, say EPV of assurance, the EPV of term assurance, then you have the annuity due and annuity arrear, or a whole life annuity due and whole life, say a temporary due annuity. So these 4 functions you need to calculate using the add-in from age 17 to 120, and then plot them in 4 different graphs, or one different graph, or one single graph with 4 line charts. Anything is acceptable here. And so this is the output required. Now if we go forward, these are some functions that you're already familiar with. You know how to calculate the EPV of assurance. So in this session, I'm only discussing EPV of whole life assurance, and I expect you to follow the same idea for the other functions as well. Then you can see here, this is a possible function that we have for the VBA code that we have for the EPV of whole life assurance. And then we are going to put this in one of the VB editor, and then see how it works. So I have this code copied in one of the sheet, and let's have a look at it. Okay, so as you can see, I have copied this mortality data in one of the sheet here called mortality, and these are the AM92 values. I have not loaded them with 10% extra, but you can do that. You can multiply each of these QX values with 1.1 and prepare your mortality data. Then I'm going to create a function here for you. So for that, I go to the VBE. This is the Visual Basic Editor, and this is where we are going to type our code. So you see, there are you will have to use a module in order to type your code here, and you'll have to create a new module. All right. So what I did, I have created this empty module here for you. We are going to save this code that I have shared earlier. So because of time constraint, we cannot type everything here. I'll explain you, however, the steps that we have followed in it. It has taken it. It was not showing it there, but it has taken it. So let me first show you what we have coded there, how it is available as a user-defined function for us. So as you can see, if I go back to my editor, I think for some of you this could be very small, not be visible clearly, but for that reason I also have this image. So this is what we have coded there. Now let me explain various steps that we have followed here. So the function that we have coded in our VBE is called AX, capital A and X, which is basically for EPV of whole life assurance. We are using X as integer, which means we want the age as integer. X is for age here. I is a double variable type. D is also a double variable type. I is basically for interest here, and D is for number of decimal points. Then we define few more variables that we would be using. These are the values which are being passed into our function AX, and we have defined few dummy variables like A1, A2. We have used limit, K, N, and PVF. So we need some working variables. If you look at that formula which we have over here. So in this formula, we want to run a loop. Each time we want to calculate the curtailed life K bar QX, multiply this with the PVF, that is PV function, and then loop this through the possible curtailed life of 0 to omega minus x. Omega minus x is the limit that we have based on the maximum age that we want, and 0 is the initial value. Now, in order to compute this, or in order to calculate this, what you need is to define the limit for the loop. For that, you need a working variable which is limit. You need to calculate the PV function, which is pretty easy because it is 1 divided by 1 plus I. You also need dummy variables to hold the temporary value while you're adding up, because it is a summation. So for that, we have used KPX, K bar QX, EPV, QX, and V. So maybe when you code it, you may work with less number of working variables, which is completely okay. I have tried using the first principles while making this code, and in order to ensure that we are able to consider each step, each iteration of our loop, and for that reason we have used these many dummy variables. Now, as you can see, this for command here, this is to run a loop from 0 to that limit which we have, and limit was 120 minus x, where 120 is my maximum age. Now this is hard coded into the VBA code, but you can allow user to give the maximum age, or you can also read through the mortality data and identify what is the maximum age possible there, and this will become customized. However, in the code that I'm showing you, it is hard coded. Then we calculate the PV factor, because for each iteration of our loop, PV factor would be different, and for that reason we take v to the power k plus 1, which is calculated as an exponential of log v, making it v power k plus 1. Log and exponential would get cancelled, and so this is a way to calculate the v to the power something. We could have used the operator for the exponential operation, but then it often results in some redundancy, and the variable may not have the exact value that we need for PV function, and for that reason this unconventional way of calculating the number raised to the power something is being used. KPX starts with 1, so this is the loop for KPX. It starts with 1. Then for 0 to k minus 1, for the current k value, we calculate the QX, wherein KPX the initial value was 1. So we find out what is the value of KPX, and then we hold the value in KPX itself. And the most important part of this code is this QX, which is basically to identify the value. So this is where we are using a VLOOKUP function from the sheets called mortality, range A2 to B105, and we are looking into the second column and querying the first column. So what we have used as A1, which is our integer value, which is basically used here as x plus n. You can see it holds the age for that particular person. So we need two loops, one to find the overall EPV and one to calculate the QX each time. So it will be an iteration, because we need QX plus K, or rather K bar QX. So it is a K bar QX is KPX multiplied with QX plus K. So it needs a recursive calculation, for which reason we have identified the value of KPX here. This KPX would further be used. You can see where my pointer is right now. This KPX value comes from here. The loop, the final value of the loop is KPX, which is multiplied with the QX value that we have identified for A2, which is the exact age for which I need QX plus K. So I multiply my KPX with that QX to find K bar QX. EPV is then a recursive value of previous EPV plus the new probability multiplied with PVF. So this is a function which uses first principles to calculate the EPV of assurance function. And what we have done here is basically to use the first principles in order to find what is the EPV of required assurance function. Now let us use this function to calculate what we have, what we want to do. Let's say for age 21 we want to calculate. So we use a function AX, okay, and you can use a formula builder here, which you can get from Control A. So once you press Control A, you can see the input that we want to have. Suppose for age 22, for an interest rate of 4%, we want to calculate this, where the number of decimal points needed is 5. And once you input this, you can see that EPV of assurance function is calculated. Some of you, when you tried to do this last time, you have encountered few errors. If you are still encountering errors, please send your specific scenario or the code that you have used, so that I can help you. If doing this produces a error for you, that simply means that either you have not coded the function correctly, or there is some mismatch in picking the values using VLOOKUP from the table. It is also possible that you're not giving the appropriate value, or you're not defined the variable type correctly. So these are few possibilities for error. Now, once we have this, uh, you know, once we have this function ready, we can also call this in other sheets. For example, this new sheet, and I call the same function again. So you can see that it works here. So it calculates the required value again. Not only this, you can also call this in a new Excel file. Suppose this is a new file that I have created. Let me call it some test file. I'll save it first. So I'm calling it test 11. Let's say this is a new workbook that you have. Now you want to use that Excel add-in. So what you need to do is call that over here. You need to add the add-in, and you'll have to browse to that file. So I think I have it here. Let me see. So this is the macro file that I've saved as XLAM. This process is explained in one of the video that I've shared with you. So I call it, and it is called EPVCal. I press OK. Now, in order for this to work, I need the mortality data also, because without that, although it would show me AX, and it would also allow me to input the values, but this will not work essentially, because we don't have the mortality file, because it seeks the mortality data from the worksheet that we have. That's how we have programmed it. So it does not create any value, it does not results in any result. So what we need to do here is copy that mortality data. So this was the data that we had, right? So this data must be present in all the worksheet that you're working with. So let me call this mortality, and it has to be named mortality, otherwise also it won't work. It reference to that data. So the table name must be same. Then copy it properly. So let me go back there. Okay, so this is the data that we have now. If we use that function, now it would work well, because we have the mortality data already added. So you can see that it produces the required output. Now, this is a simple walkthrough to help you understand how you can create a VBA calculator, or a calculator using VBA, save it as a macro file, use it as an Excel add-in to your other worksheet. And this is just a jump start for you. What you need to do is use this idea, and prepare your add-in with more functions, and then try to call that add-in to other workbook, see if it works fine. You can compare these results with your standard mortality table and see if it is working. If you're able to produce the same output, that's one validation that you have. And if it all works well, that's what your project is. And then you can send us the macro file so that we can evaluate your code. So this is how you should make the calculator using VBA, and save it as an Excel add-in. So if you have any doubt which you would like to ask, please feel free, and I'll answer all your questions now.